This is our power functions. We have that if n equals 1, the function is linear. If n equals 2, the function will be quadratic. Alright, so power functions are even if our n is an even positive integer. If x is less than a negative 1 or greater than 1, the graph will get steeper as n increases. And we'll show that here in just one second. Alright, if between negative 1 and positive 1, the graph gets flatter as n increases. So, as you notice right there, between our negative 1 and our positive 1, we have, it just gets flatter as n increases. Right, that is not the same thing as in behavior. In behavior is that we are going to travel along the x's. First of all, we're going to go along the negative infinity. So as x goes to negative infinity, we'll see what's going on, and then what happens when x goes to positive infinity. So there's our negative infinity. Here's positive infinity. What is y going to do? There's what y is doing. Now we're going to analyze it. Both of those are going towards positive infinity. Alright, now we're going to look at power functions when our n is odd. So for our function at x raised to the n power, where n is an odd positive integer, the function is considered an odd function. And when x is less than a negative 1, so x is less than negative 1. I'm just going to draw that here. And when x is greater than 1. What's going on with that? So when x is greater than 1, I'm just picking one of the functions to deal with. And as we know that as x increases, I put in too much stuff. So as n increases, our function gets steeper. Okay. Then we'll analyze between those two values of negative 1 and 1. So for when x is between negative 1 and 1, we can see that the graph gets really flat. So that as the graph gets flatter. Not fatter, but flatter. F-L-A-T-T-E-R. All right, now we're going to analyze our n behaviors again. So as x approaches negative infinity, let's get rid of this first. Now, as x approaches negative infinity, we're starting at the origin. And what's going to occur that as x approaches negative infinity, we get, there's that part. And then we'll look at what happens. It's going to go to negative infinity. That's what our y's are doing. They're going to negative infinity. Our outputs are going to negative infinity. Okay, if our x is going to positive infinity as our x inputs go in, what is our y outputs going to be? Or what is our function output going to be? F of x. It's going to go to positive infinity. Alright, let's look at the cubic. We're now going to look at the cubic parent function. Cubic parent function is when f of x equals x cubed. We're going to start out with a table of values. We're going to start out with the basic one, which is at the origin 0, 0, negative 1, negative 2, and if I put in a negative 1 and I cube it, I get a negative 1. If I put in a negative 2 and I cube it, I get a negative 8. Similarly, if I put in 1 and cube it, I get 1. If I put in 2 and cube it, I get 8. We'll just plot those functions real quick here. And there we go, and one more point. And then we are going to just connect them together. And here we go. And okay, come on. Zoop, there we go. There is, I don't graph very well, but there it is. Alright, our domain is from negative infinity to positive infinity. We do not include that, so those are in interval notations. Both of them will be parentheses. Our range is also going to be from negative infinity to positive infinity. Characteristics, we're just going to list them here. It is odd. It is symmetric about the, we have some symmetry. It is symmetric about the origin. It's a little hard to write and talk at the same time. Alright, symmetry about the origin. In other words, we should be able to take and rotate that and looks exactly the same. We can see that in the tables also, that it has symmetry in the about the origin. Okay. Does not have a maximum, does not have an absolute of this. R. We all know max. Well, I'm just going to write that down. Maximum, no minimum. And there are about 12 things that we can analyze on a function: its domain, its range, intervals of increase, intervals of decrease, x-intercepts, y-intercepts, maximum, minimum, whether or not they're absolute or relative. What are the end behaviors? So as x goes to negative infinity, our y, or output, is going to be going to also negative infinity. Is the function odd or even? That's another thing that we can analyze. Does it have any symmetry? Alright, so as x goes to positive infinity, s also goes to positive infinity. Alright, now we're going to look at the quartic parent function. Alright, quartic parent function. Again, we're going to start at 0, 0. We're going to pick our points that are close by. If you can get 2 points past where your vertex is, going to the left, and 2 going to the right, that's good, but sometimes your graphs won't let you do that because of size constraints. I'm going to go ahead and put those in. 0, 0, negative 1, negative 2. Now when I take a negative 2 and I multiply it by itself 4 times, negative 2 times negative 2 gives me a positive 4. And then multiply by another negative 2, that's 3 times, gives me a negative 8. Multiply by a negative 2 again, I get a positive 16. Alright, I'm going to just plot the points I can, which are 0, 0, negative 1, 1. And if I try to go over to negative 2 and 16, I'm going to be off the grid. So we're just going to connect those together, and we'll find out that what our domain and range and analyze its characteristics. Okay, so here's our function. We're drawing out the function. So you can see it's just a little bit fatter at the bottom than a quadratic. Again, the domain is negative infinity to positive infinity. Its range, however, and remember we are in number line order, so our number line, it starts at 0 in this case, and it's going to go to positive infinity. Happens to be even, because we can fold it on the, it's an even function. It has symmetry about the y-axis. Let's see, we have a minimum, an absolute minimum. It happens to occur at 0, 0. And unlike the cubic function, where we do not have any we don't have any intervals of increase or decrease, everything in a cubic is all increasing. Well, in a quartic, we have, coming from negative infinity, our y values, as we go along from negative infinity out on the x's towards 0. It is decreasing until we get to 0, and then at 0 it turns around, and we have what is called a point of inflection, to where it starts increasing again. Alright, that's about that. Alright, now we're going to take some of this information. We've got a couple of functions here that we're going to graph. Our f of x is x minus 3 cubed minus 2. I'm just going to create a table of values. First of all, we're going to plot our first point by moving over to the right 3. Remember, x's lie, so if it's in parentheses, we go do the opposite. And we're going to go down 2. We're going to put that first point there, and then I'm going to calculate what 2 would be and what 3 would be. And if I have some space, or if I have some extra space on the graph available, what 4 and 5 evaluates to. And that's what we ended up with. I'm just going to connect those points. There we go, just really quickly. Again, we can see that we have, it is still cubic. It is not the parent function because it has been translated to the right and down. But we still have a symmetry. Alright, so now I'm going to create another table of values. And I'm going to go, again, start with 0, 0. If I put in 0 and raise it to the 4th power, I get 0. Then I multiply by negative 1/2. I still get 0. Then I add 4 to it. So that's where I'm starting at. I'm starting out at 0, 0, and 4. Now, because this is being multiplied by a scale factor of -1/2. The value of a is -1/2. I'm going to skip 1 and pick something that is divisible by 2. So I'm going to start with -2 and +2. So -2, when I raise that to the 4th power, that will give me a +16. 1/2 of a +16 would be 8, but then you multiply that by a -1 gives me a -8. -8 plus 4 gives me -4. Okay, so now let's go and figure out the calculation for 2. When I put 2 in, 2 raised to the 4th power, again, will give me 16, and then we multiply it by -1/2, we get a -8, we add 4 to it, we get a negative, it should be both of those should be -4, shouldn't they? Oh dear. Alright, I'm going to have to regraph this. Anyway, that's the idea, that we're going to have that. And we graph it, -infinity to +infinity. And then our range is going to be from -infinity to +infinity. And then our domain would be from -infinity to +infinity. And the range is going to go from -infinity. Our maximum will still be 4. Okay, other than the graph, it should be that my points should have been at -4s on both of those. Okay.